Hi, welcome everyone. Welcome to my lab. This is Carl with Simply Works Electronics. Today I want to run down and show you the evolution of my boards and the design. Here at Simply Works Electronics, I want to be as transparent as possible. So, this video is long due. Wanted to do this a while back, but haven't had a chance to get to it. Also, wanted to use this fancy camera that I have, but the sound is not so good with this. So while I figure this out, just gonna stick to old-fashioned method of using a selfie stick and my cell phone. Anyway, let's get started. So when I started designing this, it started with revision A, and that was just more so a concept. Let me show you this board. This is unpopulated board. So that was just like a first draft of my design and just making sure that it works as a concept. Back in those days, everything was populated by hand, and well, to be honest, it's still now populated by hand partially. Anyway, so this is the first revision A, and this is how everything started. I quickly realized that I used really thin traces on this board, so this was very short-lived revision, and that was just mainly ironing out, basic circuitry and making sure it all works. Moving on, well, that was Rev A. This is what I call Rev B. So this is actually a working prototype, and I don't know, I sold probably like 50 of those boards. And that was a good start, but I wanted to streamline things a little more. Some of the components, as you can see, bulky connectors, and so I wanted to streamline some things, make a board smaller, and so the next revision was Rev C. And starting from B to C, not only the form factor changed, but also I tried to move as much components to surface mount, because that's way easier to populate with machinery and takes less work. So moving on to Rev C. Unfortunately, I don't have the first revisions. I have the earlier one that I can show you guys is the C4. And so in this one, as you can see, I moved every surface mount component to the back, and I tried to move every through hole component to the top of the board. Moving on to the next generation, as you can see, this one also had a surface mount fuse. So someone suggested, why don't you put a removable fuse? And I mean, that's a valid question. I'm not sure why I used this particular surface mount fuse. So the next revision, I moved the surface mount to replaceable fuse. The other thing I did is I had a couple snubber circuits, but I improved topology a little bit on the next revision. Also, originally I was using AC relays, and IC relays are way more expensive than DC relays. So we are the thermostat driving it with we are driving those relays with the 24 AC signal. So to make it a little cheaper, I moved on to DC relays. And as you can see on this board, we have DC relays now. And we do have, this is basically a diode bridge circuitry that translates AC signal into DC that controls the DC relay. So it just made design a little cheaper, but widely, I mean, that brought the cost down a little bit, but widely, even still, on moving on to C6, still DC relays widely for a while, and still true. The most expensive component of this board is this slide switch. So, I mean, I just went to a cheaper version. It's still functional, the same switch, just like a little simpler version of it and a little cheaper. So just trying to streamline both the manufacturing process and you know, component selection. Yeah, as you can see on C6, we already have a replaceable fuse. Another addition that I made is this MOV or varistor. Let me look it up. What's the proper name? MOV. Electronics. Okay, MOV stands for metal oxide varistor. And some metal oxide varistor, just another part that will protect our circuitry from inrush, well, more so from voltage spikes. So something, you know, to protect the board and to make it a little more robust. Okay, moving from C6 to C7, and this is the latest and the greatest. So let's show side by side. So this is C7. Basically, just overall improvements to the board, streamlining different component placements, and putting a little bigger and more reliable relays. So one of the things that was happening, and that's only, it's more so edge case if you're using, well, there's a different ways to start a motor. So there's a soft start, hard start, and everyone has a different different fan motor. So some people have older, some people have newer. So I mean, it's hard for me to predict what do you have exactly. So I'm just trying to make it as reliable as possible. But there are a few people that were affected by design flaw. So the low fan motor would, well, basically one relay, the timer relay, would get fused and it would just stay in an on position. So that was the design flaw that I acknowledge. And if you are affected by this design flaw, please let me know and I'll send you a new board free of charge. Anyway, moving to this design, bigger, more reliable relays. I improved snubber circuit topology, so which should soften inrush current when you switch on the relay, and it should prolong the life of the relay, and it should prevent the fusing of the relay. So I guess that's one big improvement in this revision. I did have snubber circuits in the older versions as well. It just wasn't the ideal topology as I have now. I just put more snubber circuits and across each controlling coil. So now it should be it should be good to go. The other couple little changes that I did to this board, I moved to 20 instead of 30 amp fuse, I moved to 25 amp, so a little lower threshold, which should add to the safety. And this is a slow blow fuse, which should be better as well. I also changed the MOF or metal oxide varistor, just do like a little beefier version of it. I did have a surface mount resistors before, so I moved to the through hole resistors, and that should just be a more reliable part that should serve you well. As you might see, this board has some jumpers, and that's because once I moved to a different relay, to a different form factor, I didn't see something. And basically, the layout, the footprint of this relay, usually it's pretty much a standard for the industry to show pins tap down on the part. But in this particular case, and I can show you, in this particular case, I didn't see this note viewed towards terminals, meaning that in this particular case, they are using view from the bottom. So basically everything became a mirror image. So the easiest solution was cut the traces and add these jumpers. I'll be updating this in the next revision. We won't have jumpers because it's kind of pain in the neck to put all of this on each board. And in the past few days, I made 50 of those boards. And just to tell you more about how those are made, I ordered them in China to keep the cost low. Now with the tariffs, it's a little more expensive to make those boards. And it's fairly cheap to purchase and put all the surface mount components. But all the through holes that you can see are still soldered by me. Eventually, I will try, and I don't know, you'll see what's the most optimal solution. But eventually, I'm hoping I can also do the through hole components at a factory instead of here in my house. But yeah, here's the rundown of this board. Get one today. Try it out. Let me know what you think. So far, most people, I'd say 98% people are pleased with this design. And I mean, the instructions can be improved, I suppose. I think the major frustration is just people don't quite understanding how to wire this and how it works. But also, I mean, a lot of people purchase it without this electronics or electrical engineering background. So, I mean, it is a hurdle. I'm trying to make it as user-friendly as possible, but, you know, there's so much I can do about it. What else? Yeah, I think this is pretty much sums it up. Yeah, try it out. Let me know what you think. If you do have older vision and you've seen this fusing problem, let me know and I will send you a board free of charge. Thanks for your attention. Thanks for supporting small business, and have a good day. Thanks, guys.